Take a question on Taylor series. Find the Taylor series expansion of f of x equals 2 power x about x equals to 0. So how to proceed here? First you write the given function. Given function is f of x equals to 2 power x where x is 0. Now what is the Taylor series expansion? We have learnt in the last class, right? So from Taylor series expansion, we have f of x equals f of a plus x minus a f dash of a plus x minus a whole square by 2 f double dash of a plus x minus a whole cube by, this is 2 factorial and this is 3 factorial, f triple dash of a plus so on. So here f of x equals 2 power x. And what is the constant a? Its value is 0 given in the question. Okay. So which implies if I put x is equal to a, I will get f of a equals f of 0. That is equal to 2 power 0, which is equal to 1. Because a value is 0 given, right? Now if you differentiate f of x, what do you get? See, this is f of x. We are differentiating this. What is the formula? D by dx of a power x is a power x log a. So when the base is a constant, we take a power x formula. When power is a constant, we take x power n formula. Got it? So we are differentiating f of x. So we will get f dash of x is equal to 2 power x log 2 to the base e we can write. Okay. So f dash of 0 will become, now wherever you have x, you put 0. So 2 power 0 log 2 to the base e, that is 0.6931. Why? Since d by dx of a power x is equal to a power x log a to the base e. Now after finding f dash of x value, we will find of f double dash of x now. How do you get f double dash of x? If you differentiate f dash of x, you get f double dash of x. So what is f dash of x? We got 2 power x log 2. Okay. So log 2 is a constant. What is 2 power x derivative? Again 2 power x log 2. Log 2 to the base e. So here log 2 to the base e, log 2 to the base e will become log 2 to the base e whole square. So if I put x as 0, we will get 2 power 0 log 2 to the base e whole square. Sorry. So 2 power 0 is 1. So log 2 to the base e whole square will become 0.6931 whole square. If you multiply it 2 times, you will get 0.4804. Okay. Now we will find f triple dash of x. How do we get f triple dash of x? If you differentiate f double dash of x, you get f triple dash of x. So in f double dash of x, you have log 2 to the base e whole square as constant. So we write log 2 to the base e whole square. Then again 2 power x derivative is 2 power x log 2. Okay, so that will become 2 power x into log 2 to the base e whole cube. Here 1 square and here power 1 will become whole cube. Understood? So now if we take f triple dash of 0, we get 2 power 0 log 2 to the base e whole cube. 2 power 0 is 1 and log 2 to the base e is 0.6931. If I cube this, I will get 0.3330. Now substituting these values, in equation number 1. So you get f of x equals f of 0 plus fx minus 0 into f dash of 0 plus x minus 0 whole square by 2 factorial into f double dash of 0 plus x minus 0 whole cube by 3 factorial into f triple dash of 0 plus so on. F of 0 is 1 plus x minus 0 is x. F dash of 0 is 0.6931 plus this is x square by 2 factorial. F double dash of 0 is 0.4804. Then here you get x cube by 3 factorial. F triple dash of 0 is 0.3330 plus so on. Now we need to write the simplified form. So how do we write it? F of x is equal to 1 plus 0.6931x plus 0.2402x square plus 0.0555x cube plus so on. Therefore, f of x is equal to 2 power x, that is equal to 1 plus 0.6931x plus 0.2402x square plus 0.0555x cube plus so on. Now we'll take up another model, that is find the radius of curvature of the curve x power 4 plus y power 4 equals to 2 at the point P1, 1. So first let us write down given curve. Given curve is x power 4 plus y power 4 is equal to 2. So from here I want to find out y power 4 value. So I take x power 4 to the other side. So y power 4 equals 2 minus x power 4. Now the radius of curvature formula we are going to apply. The radius of curvature for a curve at a point P in Cartesian form. What is Cartesian form? If the equation is in the form y is equal to f of x, that is called as Cartesian form. And if Cartesian form is given, then radius of curvature formula is rho is equal to, this is not p, this is rho. Rho is equal to 1 plus dy by dx at some point p whole square. Then again whole power 3 by 2 by d square y by dx square at some point P. This is the formula for radius of curvature in Cartesian form. So we will proceed now. We need to differentiate equation number 1 with respect to x. So what is equation number 1? This is equation number 1, let's say. Okay. And this is equation number 2. So first we need to find dy by dx. Then we have to substitute a point in dy by dx. Then we have to find d square y by dx square. Then again substituting a point. After finding these two values, substitute in this formula. So let's see how to do that. So you have y power 4. What is the derivative of y power 4? 4y cube dy by dx is equal to 2 minus x power 4 is there. 2 derivative is 0 because 2 is a constant. Minus x power 4 derivative is 4x cube. Now here 4 get cancelled. So you will get dy by dx is equal to minus x cube by y cube. So you can write minus x by y whole cube. Now if I substitute dy by dx at the given point, what is the point given? 1, 1 is the point given. So that is minus 1 by 1 whole cube. That is equal to minus 1. Now we are differentiating. Now let's say we got dy by dx value, no? We will take it as equation number 3. Now differentiating equation number 3 with respect to x. So what is the derivative of dy by dx? It is d square y by dx square is equal to minus outside. Now what is x cube by y cube derivative? See, this is, let's take this. It will be easier to differentiate. This is equation number 3. Minus I took outside. X cube by y cube we need to differentiate now. So it is in u by v form. So denominator is v square. So y power 6. Now y cube I am writing as it is. I am differentiating x cube. So 3x square. Minus x cube I am writing as it is. Y cube I am differentiating. So we will get 3y square dy by dx. Is this step clear? Now minus outside 3x square y cube minus 3x cube y square, and in the place of dy by dx I will substitute equation number 3. That is minus x cube by y cube. So minus x cube by y cube by y power 6. Now here y square and y square get cancelled. So if you take the LCM here, what do you get? This y will be multiplied with the first term because we are taking LCM. So you get 3x square y power 4. Now we multiply these two terms. Minus into minus is plus. 3x cube into x cube is 3x power 6. By this y will come down now after taking LCM. It will become y power 7. I hope it is clear to you. Now we'll substitute the point in d square y by dx square value which we got. So d square y by dx square at some point p, that is 1, 1 given in the question. That is minus of, now we will substitute 1 and 1 in x and y. So 3 into 1 square into 1 power 4 plus 3 into 1 power 6 by 1 power 7. So that is minus of 3 plus 3. That is minus 6. Okay. Now substituting the corresponding values in equation number 2. Equation number 2, corresponding values in equation number 2. Equation number 2 is the radius of curvature formula. So rho at 1, 1 is equal to 1 plus minus 1 whole square whole power 3 by 2 by minus 6. That is 2 power 3 by 2 by minus 6. So if you find this value, this is square root of 8 by minus 6. So if you solve this value, you will get minus 0.47. This is the question. Find the radius of curvature at the origin of the curve. X power 4 minus 4x cube minus 18x square minus y is equal to 0. So first we will write given curve. Given curve is x power 4 minus 4x cube minus 18x square minus y is equal to 0. So from here, I will take minus y to the other side. So we will get y is equal to x power 4 minus 4x cube minus 18x square. So it is in the form y is equal to f of x. So this is called as Cartesian form. Okay. So now we have a formula for radius of curvature. So write the same formula which we have written in the last problem. The radius of curvature for a curve at a point P in Cartesian form, y is equal to f of x is given as same formula, rho is equal to 1 plus dy by dx at a point P square whole power 3 by 2 by d square y by dx square at some point P. And here the point P is origin, that is 0, 0. So now we'll see how to find out dy by dx. So what is dy by dx? Y we got it as x power 4 minus 4x cube minus 18x square. So if we differentiate that, let us take this as equation number 1 and this as equation number 2. So we are differentiating equation number 1 now. So you get x power 4 derivative is 4x cube minus 4 is a constant. X cube derivative is 3x square minus 18 is a constant. X square derivative is 2x. So that is 4x cube minus 12x square minus 36x. This is dy by dx. So if I substitute dy by dx at some point P, that is origin. So 4 into 0 cube minus 12 into 0 square minus 36 into 0. Everything is 0, so dy by dx at some point P will become 0. Now we will take this as equation number 3. And now we differentiate equation number 3 with respect to x. So if I differentiate dy by dx, I get d square y by dx square. That is equal to 4 into x cube derivative is 3x square minus 12 as it is. X square derivative is 2x minus 36 into x derivative is 1. So minus 36 x derivative is minus 36. Now again we will substitute a point P, that is 0, 0. So this will become 12 into 0 square minus 24 into 0 minus 36. So the final answer for d square y by dx square at some point 0, 0 is minus 36. Now substituting values in equation number 2. So what is equation number 2? Rho is equal to 1 plus, what is dy by dx? 0. 0 square whole power 3 by 2 by, what is d square y by dx square? Minus 36. So that is 1 power 3 by 2 by minus 36. 1 power anything is 1. So the answer is 1 by minus 36. This is the radius of curvature. Now let's take up another question, that is find the radius of curvature at the origin for the curve x power 4 minus y power 4 plus x cube minus y cube plus x square minus y square plus y is equal to 0. So in the last two problems, we easily found y value because there was only one y term. But here you have multiple y terms. So it is difficult to find out y value. So in this case, let's see how to find radius of curvature. So first we will write the given curve. So given curve is x power 4 minus y power 4 plus x cube minus y cube plus x square minus y square plus y is equal to 0. Now what is the radius of curvature? Formula. Here we use a different formula. The radius of curvature for a curve at origin, whenever at origin is given, we can use this formula directly. That is rho naught. Rho naught means radius of curvature at origin is equal to 1 plus a square. In the place of dy by dx, we are taking a square whole power 3 by 2 by b. In the place of d square y by dx square, we are taking b. Okay, so the new formula is rho naught is equal to 1 plus a square whole power 3 by 2 by b. So let us take y is equal to ax plus bx square by 2 plus cx cube by 3 plus so on. Let's take this as first equation, this as second equation, this as third equation. Now let us substitute equation number 3 in equation number 1. Now we will see how to substitute equation number 3 in equation number 1. So look at equation number 1, how I am substituting. So x power 4 minus, now in the place of y power 4, I am substituting ax plus bx square by 2 plus cx cube by 3 plus so on, power 4. Then you have x cube term. I am writing x cube as it is. Minus, now in the place of y, I am substituting equation number 3. So ax plus bx square by 2 plus cx cube by 3 plus so on, whole cube, plus. Again you have an x square term, minus. Now you have y square. So again in the place of y, we substitute this. Ax plus bx square by 2 plus cx cube by 3 plus so on, whole square, plus. Now in the place of y, we substitute ax plus bx square by 2 plus cx cube by 3 plus so on is equal to 0. Now we are comparing coefficient of x on both sides. So now if you see x, where do you get x coefficient? You get only here. Because in every bracket you have power 2, power 3, power 4. So definitely you will not get x term there. You will get only x term from here. So what is the coefficient of x here? That is a. So you will get a is equal to 0. Right hand side is completely 0. Left hand side coefficient of x is a. So we get a is equal to 0. Clear? Now we will compare coefficient of x square on both sides. So x square on both sides means, now from where do you get x square? X square coefficient. You get x square coefficient from this whole square term also, and here also x square term. So here x square coefficient is 1. Then here x square coefficient will be, see if you expand this bracket, you will get a square x square. This whole square will become a square x square. So x square coefficient will be a square. And before the bracket you have a minus sign. So we get minus a square. Understood? Then from here you get x square coefficient. What is x square coefficient here? B by 2. So you get plus b by 2 is equal to 0. Now you put a is equal to 0. We got the value. So 1 minus 0 plus b by 2 is equal to 0. So from here you will get, if I take LCM, we get 2 plus b is equal to 0. So b is equal to minus 2. Now substituting a and b values in equation number 2. So we got rho naught is equal to 1 plus 0 whole power 3 by 2 by minus 2. That is 1 power 3 by 2 by minus 2. So radius of curvature at some origin is minus 1 by 2, because 1 power 3 by 2 is 1 again. 1 power anything is 1. And this minus, I bring it to the numerator. And in the denominator, you have 2 as it is. So this is the final answer. Take another question. Find the radius of curvature of the curve x equals to a cos t, y equals to b sin t, at t equals to pi by 4. So first let's write what the given curves are. So given curves are x is equal to a cos t. This is first equation. And y is equal to b sin t. This is second equation. Now what is the radius of curvature formula? Here we will apply another formula. We cannot apply first and second formula which we have used in our previous problems. So here we use parametric form. Why we are using parametric form? because x is also given in terms of t and y is also given in terms of t. So then it is called as parametric form. Okay, so in parametric form, the formula is, I'm writing it over here on the right hand side. So radius of curvature is denoted by rho, that is dx by dt whole square plus dy by dt whole square whole power 3 by 2 by dx by dt into d square y by dt square minus dy by dt into d square x by dt square. Let's say this is equation number 3. Now we differentiate equation number 1 and 2 with respect to t. So how do I get, if I differentiate equation number 1 with respect to t, x will become dx by dt. A I am writing as it is because A is a constant. Cos t derivative is minus sin t. So that is minus sin t. So your dx by dt will become minus a sin t. Now if I differentiate equation number 2, we get dy by dt is equal to b is a constant. Sin t derivative is cos t. So we got dx by dt and dy by dt. Now after finding dx by dt and dy by dt, if you differentiate this dx by dt and dy by dt again with respect to t, you get d square x by dt square and d square y by dt square. So let's find out d square x by dt square. So that is differentiating dx by dt with respect to t. So dx by dt is minus a sin t. So minus a is a constant. Sin t derivative is cos t. Then how to find out d square x, y by dt square? We differentiate dy by dt again with respect to t. So dy by dt we got it as b cos t. So that is b into cos t derivative is minus sin t. So that is minus b sin t. Now after you got d square y by dt square and d square x by dt square, we substitute all the values. So let's write substituting corresponding values in equation number 3. So you get radius of curvature is equal to a square sin square t plus b square cos square t whole power 3 by 2 by, in the formula you have dx by dt, that is minus a sin t, into d square y by dt square is minus b sin t. Now minus dy by dt is b cos t, and you have in the formula d square x by dt square minus a cos t. So that is a square sin square t plus b square cos square t whole power 3 by 2 by, if you multiply these two, you get ab sin square t plus ab cos square t. But from trigonometry, we know that sin square t plus cos square t is 1. So that is a square sin square t plus b square cos square t power 3 by 2 by ab. Now we find radius of curvature at some t is equal to pi by 4. So that is a square. If t is pi by 4, sin pi by 4 is 1 by root 2. And 1 by root 2 whole square is 1 by 2 plus b square into. Now cos t. T we are taking as pi by 4. So cos pi by 4 is 1 by root 2. 1 by root 2 whole square is 1 by 2 whole power 3 by 2 by AB. So that is a square plus b square power 3 by 2 by 2 power 3 by 2 AB. This is the final answer.